What's up, guys? Welcome to another class of chemistry. Before I start though, I just want to say it's the 7th presentation, which means it's one more presentation after this. I had a total blast with this class. Yeah, I hope you guys will enjoy this presentation. Today I will try my best to explain electron domain geometry. And I have a little guidance here because I just want to make sure that the specific words that I say are clearly to be understood and that you understand each models that I will be explaining. And yeah, whenever you have questions, of course, just comment below. So, electron domain geometry. So basically we are talking always about, you have an atom, which basically I put here like a smaller balloon in each of these models. Like here's the blue in all of those, here's the blue, and here's the white one. So this is the atom, and surrounded via bonds are the electrons, okay? So basically we're talking about bonds and lone pairs. Each have different molecules, different electrons, lone pairs, and I will also give you an example. So there's different types of electron domain geometry. And actually we have 2, 4, 6, 8. I will be talking about 8 different types. Some of them I can use the same amount of balloons, but there's still a difference. I will explain. And yeah, just let's start with the smallest one. I want to say smallest one because this one basically is called, this electron domain geometry is called trigonal planar. And it's basically because of the shape. We have the atom and it has 3 electrons. So 3 electrons, we have 1, 2, 3, and again surrounding the atom. And it's because of the trigonal, it's the trigonal shape. It has one lone pair, and for instance, an example would be SO2, which is sulfur dioxide. The molecular geometry, the shape would be bent. It's because if you look at the real example, if the real molecular geometry, you can see a bent shaped. And the type of molecule, it is AB2. So when I'm talking about AB, it's basically 2 different electrons forming an angle between them and the atom in the center. So, and 2 means there's 2 different ones. So we have the angle A, B, and the atom. And then there's another one, a different angle, a different type of amount of degrees. So that's why we say AB2. If there was only one angle, one and the same angle with all of them, then we would have AB1. So yeah, so this is this one. Trigonal planar is the electron domain geometry. The molecule is AB2. I gave you the example SO2, which is sulfur dioxide, and the number of lone pairs is 1. So what is the lone pair? Lone pair is basically a pair of valence electrons which are not shared with another atom in a covalent bond. So that's what a lone pair is. So when I talk about the lone pairs, the number of lone pairs, now you understand what that is with the other examples. So now I hope you have some clarity about what I will be talking about. So this was the first one, 3 electrons, type of molecule AB2, right? I explained that. The electron domain geometry is trigonal planar. Number of lone pairs is 1. And basically for molecular geometry, the shape is bent, and that's the first model, and I will be putting this out of the way. So let's go on to the next one. So for the electron domain geometry, we have now tetrahedral. Tetrahedral is the electron domain geometry. For that, we're gonna grab this type. This type, it has 4 electrons. So this tetrahedral electron domain geometry, it has 4 electrons. So, but we can use, there's 2 different types. So 2 different types. So one has 3 AB bonds, and one also has 2 AB bonds. So that means the bonds between its electrons and the atom, there's 2 different angles. So basically we're talking about the bond angle. So there's 2 different ones, and in another model, like the one with 1 lone pair has 3 different bond angles, and we also have one that has 2 lone pairs and that has only 2 bond angles. Okay, so we have this model, there's 2 different types, we have 4 electrons, we have the atom in the middle, and basically the shape is basically we have the 3 electrons on the down part, we have the atom in the middle, and we have the, I hope you guys can see this, and we have the other electron on top. So that's the tetrahedral shape. But we have basically one in the same shape, but one electron domain geometry has 2 bond angles. The molecule has its AB2. So it has 2, again, I tried to explain this to you. So it has 2 different angles. So between the electrons and the atoms, and between another electron and the atom. So there's one that has 2, and there's another one that has 3. So the one that has 3, AB3, is the one that only has 1 lone pair, and the one that has 2 is the one that has 2 lone pairs. So one has a trigonal pyramidal shape as far as the molecular geometry, and another one has a bend shape. So for the bend shape, a simple example is water, and for the trigonal pyramidal molecular geometry, we can give an example, which is ammonia, which is NH3 ammonia, and the water is H2O. So I hope you guys understand this. Please, if you don't, I'm happy to come back and explain, but in the comment sections, you know, please don't be shy, no problem, okay? So we have now, with the 4 balloons, we have 2 different ones. One has 1 lone pair, one has 2 lone pairs. The type of molecule with the 1 is AB3 that has 1 lone pair, and the type of molecule AB2 is the one that has 2 lone pairs. Again, 1 atom, 4 electrons, but different shapes as well. So let's move on to the next one. So there's now 3 different types. So let's talk about the electron domain geometry. So for the electron domain geometry, the name is trigonal bipyramidal. Okay, so, and as far as the shape, so we have basically 1 electron on the bottom, 1 electron on the top, we have the atom in the middle, and we have basically 1 electron on the side, sticking out on the side, and the other one's here on the side as well. So what is the difference? Why 3 different ones? Well, like I said, trigonal bipyramidal is basically, there's 3 different types of this electron domain geometry. So one has a AB4, it's the type of molecule. Again, it's different type of angles between the atom and in the middle and the electrons. Different electrons form a different bond angle with the atom. So we have 4 of those, that's why AB4. and only one lone pair. That's the one with one lone pair, and it has like a seesaw shape. And an example for that is sulfur tetrafluoride, which is SF4. Okay, so we have that. Then the next one, also again, we have 5 electrons. The molecule type is AB3. So this one has, again, 5 electrons, 1 atom, but only 3 different bond angles. So that's why AB3. And this one has 2 lone pairs, and the shape, it's more T-shaped. See, as you can see, it's this one on top, this one, and this one. And then we have the atom in the middle, and then right out here, like forming a T. Those 1, 2, and 3 have a T shape. Example for this is ClF3, which is chlorine trifluoride. Okay, so the last one of the trigonal bipyramidal electron domain geometry, again 5 electrons, and we have AB2, which means it has only the electrons in total only form. There's 2 different bonds between, or bond angles between the electrons and the atom. So there's maybe this one and this one is one angle, and then another one forms the same angle, and there's no other. You know, for instance, one has 90, another one has 90, and then there's another one that has 180. You know, so because this way you build all these angles and together as a 360. Okay, this is just an example. Okay, so don't get stuck on that. So the number of lone pairs now has 3. Again, a lone pair is a pair of valence electrons that is not shared with another atom in a covalent bond. So the shape now is linear. Linear meaning, let's look at this balloon here, or the electron here, the electron there, and the atom, and stretch it out so that it's straight. It's going straight, it means linear. Okay, and for that example, we have IF2-, which is iodine fluoride. Okay, so now for 5 electrons, this electron domain geometry again is trigonal bipyramidal, and we have 3 different types. Let's move on to the last one, which gives us 2 types. We have 2, 4, 6 electrons, 1 atom, and this electron domain geometry is called octahedral. Okay, the 2 differences. One, again, has AB5, so we have 5 different bond angles between the electrons and the atom in the middle. The number of lone pairs is 1, and the molecular shape is square. It's basically square, pyramidal, so it looks almost like a square, and it has like the atom in the middle and one standing up, one balloon standing up, or 1 electron is above. And an example for that is BRF5, which is bromine pentafluoride. Okay, so I really try to, you know, explain those type of different domains or electron domain geometry. So, you know, that's why I wrote it down. I have it here as a guidance so you understand. And still, if you don't understand, always ask questions. So now the last one with the 6 electrons, again in octahedral electron domain geometry, the molecule type is AB4, because in this one we only have not 5 but 4 angle bonds between the electrons and the atom, 4 different angle bonds, and this one has 2 lone pairs, so the number of lone pairs is 2. The shape is square, planar, and that's the molecular geometry. And an example for that is XeF4, which is xenon tetrafluoride. So guys, so that's basically it as far as electron domain geometry and their molecules, their lone pairs, their shapes, and the examples. I hope you understood everything. I hope you enjoyed this presentation. If you have any questions, just comment below. Again, thank you for watching. Always